Okay, for any positive integer n, prove that nq minus n is divisible by 6. That's the same problem. You take a is equal to this much. Yeah, that is how we had started yesterday. Divisible by 2 and 3, then it is also divisible by 6. The sum of the digits of any number is divisible by 3. Then also it is divisible by 3. And if one of the factors is 2, then also okay, fine. There is no problem with the logic. N is any positive number, no? They are saying that n is any positive number. So now, for example, let's see whether it works out or not. I don't know. Maybe I'm just not getting, I'm not seeing it through. Maybe I may be also wrong. Let's check it out. Okay. So they're saying that n is any positive number. So let's take n is equal to 17. Okay. Yeah. So I was saying is we have to check whether n cube minus n is divisible by 6, right? So for now we are checking whether n cube minus n is divisible by 3. Okay. And you know that it can be written as n into n minus 1 into n plus 1. So what they are doing is, instead of considering this n as a number, they're just taking it as a digit. But let's see whether it works that way or not. Okay, so if you take n and then you add n minus 1 and then you add n plus 1, what really happens? They're saying that this minus 1 and plus 1 cancels and this becomes 3n, right? That's what they're telling. Is that correct?
Yes, sir.
Okay, so now let's take n is equal to 17. So if n is 17, then what will happen? What will happen to your n cube minus n? It will be 17, 17 minus 1, and then 17 plus 1.
Sir, this is wrong, sir. I checked, sir. If you multiply 17 into 16 into 18, we are getting something 4,800, sir. Then if you multiply 17 into 17 into 17, then we are getting something 4,900, sir.
Yeah, multiplying or adding, that's not a problem. What they are doing is they have just added all these numbers instead of adding the, see, when we have a number like 376, we have to add the digits of this, no? 3 plus 7 plus 6 to check whether this is divisible by 3 or not.
Oh, yes, sir. Yes, sir.
Okay, we have to add the digits of the number, not the number itself. We should not add 17 plus 17, 17 plus 16 plus 18. That is what they are doing, correct? You understand that? All of you?
Yes,
all of
sir.
you? So, see, ultimately we know that this n cube minus n, we have already proved using Euclid's division lemma that no matter what happens, it is divisible by 6, right? It is divisible by 6. So it will be divisible by 3 also. We know that it will be divisible. But this proof, I don't think this is a right way to prove it by adding the numbers itself. This is not a way of adding numbers. No, we should not add numbers to tell that it is divisible by 3. Because in this case, we already know that it is divisible. That's why this also shows you that it is divisible. But this is not the way to prove it. Let me try to take another example. So if I want to find out whether 3 into 4 into 5, if this is divisible by 3 or not, what do we do? Do we add 3 plus 4 plus 5 and then check that it is divisible by 3 or not? 5 plus 4, 9, 9 plus 3, 12. It will be divisible because if there is a number which is divisible, 3 consecutive numbers are there. One of them always have to be 3 at least. It has to be a factor of 3. Correct? So it is going to be divisible, but this is not the way to prove it by adding the numbers itself. If you want to check whether it is divisible by 3, you have to check whether 3 is one of the factors or not. Don't use this method in your exams, okay? In your board exam, don't use this method. Because they are not actually proving anything over here. They have said that n minus 1 into n plus 1 must be even anyway. So why should it be even? That is what we have to prove it, okay? If it was like 1 or 2 mark question, maybe you could have done, like this question normally will be of 3 marks at least. So for 3 mark question, you should not just assume by itself that it is already divisible by 2 or divisible by 3. Fine. So we will not be using this method as of now. But if somehow I figure out and find out that this method can be used, I will let you know. Okay, I'll check it out. But I don't think this method is the right way to solve this problem. Any problem like this, divisibility problem from the first chapter, you will use Euclid's division lemma to prove it. Okay. And like I said, I showed you two different methods. First method, we used directly 6. We divided the number by 6 itself, and then we understood that in all those cases, at least 6 will be a factor of all of them. So it is divisible. And then I told you that it can also be done by proving that it is a factor of 2 and 3 separately. This will actually reduce it to 5 steps. In the previous one, you had to show 6 cases. Here, there'll be only 5 cases. 2 cases for divisibility of 2 and 3 cases for divisibility of 3. So 3 plus 2, 5 cases will be there. Okay. So you can actually follow this method, the second method. I had already showed you how to do the divisibility by 2, and you were supposed to try it out, the divisibility of 3. So how many of you have actually done that? How many of you tried this divisibility of 3 and cube minus n?
Sir, I
Done.
completed, sir.
Okay, that's good. So yeah, so do I need to do this divisibility of 3? Anyone needs help with this? Tell me.
Sir, can you do it, sir,
Sir,
so
can
that
I
I
do
can
it?
check mine?
Yes, okay, I'll do that. Okay. See, I will repeat the whole thing again, just quickly. Understand that if I want to prove that n cube minus n is divisible by 3, what is that n over there? N is some positive number, no? They are saying that n is some positive integer. So if it is some positive integer, how can we represent it? How many ways are there to represent it? It can be represented in infinite ways, actually, you know, right? It can be represented in infinite ways. But if I want to prove the divisibility by 3, what we do, we pick one special type of that representation. We take this number n and we divide it by 3. So if you divide any given number by 3, there are only 3 ways to represent it. You know the Euclid's division lemma. So our A becomes n and B becomes 3. All of you remember A and B of Euclid's division lemma? You can represent any number A as BQ plus R, where R is greater than 0 and less than B. This is the representation of any number. So if I do a division by 3, then n can be written as 3q plus R. In place of R, what we can say, where R is what? What are the values it can take? It has to be greater than
0,
0,
1, and 2.
and it has to be less than 3. So if I do a division by 3, then n can be represented in 3 different ways. If I do a if I chose some other number, if I did a division by 8, there will be 8 ways to represent the number, but I'm doing it with 3 right now. That's why there are 3 ways to represent it. What are those 3 ways? I can represent n as 3q plus 0, 3q plus 1, and then 3q plus 2. These are the only 3 ways in which any positive integer in the world can be represented. So all these 3 ways, if I prove that they are always divisible by 3, then that means any number n will always be divisible by 3. Correct? So actually we are not proving that n is divisible by 3. We are proving that n cube minus n is divisible by 3, not n directly. N will of course not be always divisible by 3. N could be any positive integer. It could be 1 also, 2 also, 3 also. But no matter what number you take, if you take n cube minus n, so n cube minus n will always be divisible by 3. How can we do that? How can we check it? By taking all these 3 different cases and proving that they are divisible by 3. So let's do that. Write the 3 cases and just prove it. Is that how you people have done?
Yes, sir.
We'll say, how do we write it? We say r is equal to 0. So n becomes 3q plus 0, that is 3q. So this is your n value. So this is one way of representing n, 3q. So if this representation come into picture, then let's see whether n cube minus n, which is n into n minus 1 into n plus 1, is it divisible by 3 or not? So in place of n, what will we put? 3q. So 3q into 3q minus 1, and then 3q plus 1. So what we can do, we can separate all the other factors and just leave our 3 alone. So 3, this whole thing, n cube minus n, we can see that it is divisible by 3 because 3 is a factor over here. So we can say that this whole thing can be represented as 3m, where m we can write it as q into 3q minus 1, 3q plus 1, which is some integer. So this implies that n cube minus n is divisible by 3 for this representation 3q. Same way we'll check for case 2 also. Do you people want me to write that case 2 and case 3, or you understood the flow, guys? Do you want me to do that? We have been doing this so many times, like this one.
Understood.
Understood, sir.
Okay, Nitya, you understood, right?
Yes, sir.
Yes. I'll just write one more step. R is equal to 1. So this time n will be 3q plus 1, and then you will write your n cube minus n as n into n minus 1 into n plus 1, and just put those values over here. 3q plus 1, 3q plus 1 minus 1, and 3q plus 1 plus 1. So as you can see, this plus 1 minus 1 get cancelled. There will be only 3q remaining. So again, that 3q comes out. So it will be 3q times of 3q plus 1 and 3q plus 2. So again, there is 3 is a factor over here. So I can write this as 3m, where m is some integer. And we can say that m is equal to q times of 3q plus 1 and 3q plus 2. Other than 3, whatever we have over here, everything we call it as some integer m, because that will be integer only. No, q is some integer. So if q is an integer, q into 3q plus 1 and 3q plus 2, this will also be some integer. We don't care what that is. So again, this is a factor of 3. This is divisible by 3. Same way we will do for the third case. R is equal to 2, and you will show that, okay? And then since there are only 3 ways to represent n, and in all those 3 representations, we saw that n cube minus n will always be divisible by 3. Therefore, we can say that for any value of n, no matter how you write your n cube minus n will always be divisible by 3. And then after that, you have to just write one more statement that since n cube minus n is divisible by 2 also and divisible by 3 also, therefore it is divisible by 6. That's the additional statement you will have to write. Okay, let's move on to the next question now. Actually, we have spent enough time on this question. So you people were asking me second question and then sixth question, right?
Yes, sir.
Yeah, so I think most of you know how many stacks are there, or how many suites can be put into each stack by finding the HCF, right? HCF is the
30, sir.
Yes, sir. 30.
yes. So each stack will have 30 burfis.
Sir, I am having confusion in 12th question.
Sir, so how should we found how many stacks are there?
Yes, we'll get to that. Okay, and Hari will get to the 12th question also. This question will not take much time. Don't worry. It will not be like the second question. So let's finish this very quickly. Okay. So yeah, question 6. So I'm not going to find the HCF. You people know how to find HCF. So HCF, you got it as 30. HCF of the two numbers. What were the two numbers, guys? Tell me.
420 and
420
150.
Yeah. So what they were saying. The question again. Yeah. So these are the number of burfis. So 420 kaju burfis and 150 badam burfis are there. And you found that the HCF of these things is 30. So we can make a stack of 30. 30 will divide both these numbers exactly. So how many stacks will be there? So what you can do, you can find for Kaju Burfi, how many stacks will be there? 420 divided by 30. Each stack has 30 sweets. So how many stacks are there? 420 by 30
40.
only, no? Right? So there are 14 stacks of Kaju Burfi. And for Badam Burfi, how many stacks will be there? 150 by 30. So it will be 5. There will be 5 stacks of Badam Burfi. So there is a total of 14 plus 5, that is 19 stacks of sweets are there. Does it make sense? Very simple thing. Each stack has 30 sweets. So if there is a total of 420 Kaju Burfis, how many stacks will be there? 420 divided by 30. There's a total of 150 Badam Burfis. So each stack should have 30. So 150 by 30, that will give you 5 stacks of Badam Burfi. 14 plus 5, there will be a total of 19 stacks will be there. Nitya, is it clear? Confirm? This was your question.
Yes, sir.
You only asked this, right? Okay. Yeah. So let's move on. 12th question. That's the next one. Anybody has any other questions before that? No, right? Okay. So what is this 12th question? Show that. Okay. This question is also very simple. Showing that 3 plus root 7 by 5 is irrational when root 7 is already irrational. We know that. So what do we do normally in this kind of question? We assume that what was that number? Tell me, guys. Nobody?
3 plus root
3
7
plus
by
root
5.
3 plus root 7 by 5, correct? Okay. So let's assume that 3 plus root 7 by 5 is rational. They're asking us to prove irrational. We assume the opposite, that it is rational. So if so, then what will happen? If it is rational, then we should be able to represent it like 3 plus root 7 by 5 can be written as a by b, where a and b are co-prime integers. And b is not equal to 0. Okay. Every rational number can be written in this form, right? A by b form, where a and b are co-primes and b shouldn't be 0. Then what we do? We move around these variables. Like we, except for root 7, send everything, transpose everything else to the other side. So when 5 goes to the other side, it will become 5a by b. So it will be 3 plus root 7 is equal to 5a by b. Now transpose this 3 also to the other side. So it will be root 7 is equal to 5a by b minus 3. What do we do now? Guys, tell me.
rational, sir. Root 7 is equal
Yes.
to.
We say that root 7 is irrational. We know that. It's given in the question also that root 7 is irrational. But what about the RHS? 5a by b minus 3. Should it be rational or not?
Rational,
It should be rational.
Right.
Why? Because
as we assumed.
a and b are integers. If a and b are integers, then 5a will also be an integer. B will also be an integer. And minus 3, of course, will also be some integer only. It doesn't have to be integer, but it will be some fraction or integer. It will be a rational number somehow.
Sir, not as we assumed.
See that again?
Sir, it is rational, but like as we assumed only, no, sir, it is rational.
But actually it is irrational, no? This number is irrational, but we assume the opposite, that it is rational. We make the incorrect assumption. And then we come to a contradiction. There is a contradiction here. Why did this contradiction appear? Irrational number becomes equal to rational number. Why did this contradiction happen? Because we made a wrong assumption here. we assumed that it is rational when it was not. Okay, go through the videos, guys, recordings. We have done questions like this, and I have explained this again many times. So make sure you
Sir,
make use. Yeah.
Sir, I got confused when it says root 7 is irrational. That's why I asked you, sir.
Oh, is there something wrong in the question? Did I write it
No,
wrongly?
no. I got confused.
Okay, because it was written that root 7 is irrational. That's why.
Ah,
Okay, yeah, see, normally if you ignore this part, show that this is irrational. This is the same question, okay? This is the extra statement. They have told you that you do not need to prove that root 7 is irrational. When you come across this contradiction here at the bottom of this place, here you see that you don't need to prove that root 7 is irrational. It is already given in the question that root 7 is irrational. Okay, that's the only thing.
okay, sir.
Okay, so everyone is clear with question 12?
Yes, sir.
All right. Then what other question? So I think everyone should be okay with 13, 14. I think 15th question I have not taught you people, so that's all right. I will teach you, okay? So the number is root 2 and root 7. Okay, understand one thing. When you have irrational numbers within the roots, so if I take 2, root 3, root 4, root 5, root 6, root 7, all these are, if you write numbers like this, the value of these numbers, they are in ascending order. Do you understand that? Root 3 will be bigger than root 2. Root 4 will be bigger than root 3. They are all in ascending order. Everyone understands that? So in the same manner, if you have root 2 and if you take root 2.5 and then root 2.8, they are still again in the ascending order. So bigger, the square root of a bigger number is bigger than the square root of a smaller number. You understand this logic? All of you confirm quickly.
Yes, sir.
Okay, so in this case, you have a root 2 and root 7. So this thing is very simple. Root 4 is a number which will be lying between root 2 and root 7. Okay. So it's very easy to figure out that root 4 is a rational number which lies between those two. But in some other questions, it may not be that easy. So I'll show you another method. Like let's say there is no number like root 4. Perfect square number was not there in between. Then what to do? So what you have to figure out, we have to figure out some decimal number whose square root will be easy to find out. Can you think of a number, decimal number between 2 and 7? Forget about the root right now. So find some decimal number between 2 and 7, which will have a perfect square root.
2.5, sir.
2.5. Okay, yes, that is right.
6. Root 6.
Root.
Oh, no. Root 4.
See, if I take 2.5, what happens? We get a square root of 2.5, and this becomes 25 by 10. So we get a 5 by. Still, I get a square root of 10 in the denominator. So I would not want a number which is only having one digit in the decimal place. I want two digits in the decimal place. So think of a number like 225, 2.25. Can you think like that? So
What?
if I take 2.25, what is the square root of 225? Do you people remember? 15, right?
15.
Okay, so 225 we can take and then write it as 2.25. So we know that square root of 2.25 will lie between these two numbers. So I can write this square root of 2.25 as 225 divided by 100. Everyone understands how that happened? I just removed the decimal and wrote the 100 in the denominator. So now both these numerator and denominator, both of them are perfect square numbers. So it will be very easy to write. It will become 15 by 10, which you can simplify further, and you can write it as 5 3s are 15 and 5 2s are 10. So 3 by 2. So when you write a number like this,
Sir, 6.25, sir.
yes, absolutely, very good. We can take 6.25 also. So 625, the square root of 625 is 25. So that can also be taken. So I will take it as 625 by 100. So it will become 25 by 10. So 5 5s are 25 and 5 2s are 10. 5 by 2. That number also lies between square root of 2 and square root of 7. So
2.56, sir. Root.
okay, 256. What is the square root of 256?
16.
Okay. So the same thing you will do here. 256 by 100 and it will become 16 by 10.
$1.44.
Yes, 1.44. 1 we should not take because the number should be more than 2 and it should be less than 7. But in some other case where they were asking you to find some other thing, any perfect square number is possible. But you understand why we can't take 1.44, right? 1.44 will be smaller than 2. I don't want a number which is smaller than 2. I want a number which is bigger than 2 and less than 7. So I can take 2.25 or 2.56 or any other number like that up to 6.25. Or even more number which is perfect square. And it should be less than 7, but remember, greater than 2, but less than 7. Everyone understands the logic? Guys?
Yes, sir.
I didn't get confirmation from other people. If you have not understood, let me know. I will
Yes,
explain it
sir.
again.
Yes, sir.
Understood, sir.
Yes, sir.
Okay, so make sure you go through the recording and then try to sort it out, the logic. I've explained in the live class. I take so many examples and I speak so many things. So sometimes some people may not be able to get it. So that is why I'm making all that hard work and uploading all that recording for you so that you can go back and revise it. Because in the recording, you have an option to fast forward, skip a few steps, which you already understood. But make sure all of you, it's at least once you should go through the recording. Because in the class, you may feel that you have understood everything what I said. But once you go through the recording, sometimes I've told you this before also. There will be some things which I will say in a very, I will just tell you and I'll move on. Maybe even I don't remember to tell it very clearly. So you will think that you understood everything, but you would have missed a small point about it. And that will give you trouble to solve some problem someday. So don't take it lightly. Make use of the recordings, okay? At least browse through it and make sure that whatever I have said, everything you should understand. Because I am also human, and in a live class, I may not say everything in a proper order. I may not say everything incorrectly. So once you go through the recording, you may even catch some mistakes with what I say. That happens actually. I have gone through the recording, and in the flow of saying something, I will make some silly mistakes. That can happen. So you should not get confused by that. You should get it clarified with me. You should come back to me and tell, okay, sir, you said this in the video yesterday. I saw. So you people are not doing that. You're not finding my mistakes. You should do that. Okay. Fine. So yeah, that's it. I think this all the types of questions we have done. And this chapter is complete. So we'll try to keep a test for this next Monday, okay? You'll have a test in real numbers coming Monday. Okay, yeah, so the next thing is now we need to start a new chapter. From tomorrow's class, we will start the third chapter, pair of linear equations in two variables.